SwayamPrabha. Digital India. Educated India.
We start our discussion today on this topic thermal engineering basic and applied, and today we shall discuss about the reheat cycle. And while discussing about reheat cycle, again we shall try to see several issues which are involved with this particular cycle. But you know that if we try to recall, in the last class we have discussed about the modifications of simple Rankine cycle. In this context, we have also discussed the effect that due to the lowering the condenser pressure, and in continuation of that particular aspect of enhancing the efficiency of the cycle, today we shall briefly discuss about other two possible ways by how we can increase the efficiency of the simple Rankine cycle. We shall discuss both the merits and demerits associated with the modifications that we are going to discuss today, and also we shall discuss that the modifications, even after having these modifications with the simple Rankine cycle, still this cycle cannot be considered in the real power plant, essentially because of some disadvantageous features. And while we are talking, we shall be talking about those disadvantageous features, reheat cycle seems to be an alternative, and we shall discuss this part again. So, you know that if we try to discuss about modifications of simple Rankine cycle, number one that we have already discussed in the last class, that is lowering the condenser pressure. Number 2 and number 3 that we are going to discuss today are the superheating the steam, beyond that particular point, that is point 3. So, if we try to draw the TS diagram here, so we have discussed that this is the simple Rankine cycle, this is P condenser and this is P boiler. So, this is point number 2, this is point number 3, this is point number 4 and this is point number 1. So, superheating the steam beyond point 3, that would be an alternative to enhance the efficiency of the cycle, that is quite visible if we really look for this TS diagram. Okay, we shall discuss today that point. And finally, another important point is, that is increasing the boiler pressure. So, today we shall discuss these two aspects one by one. Let us first look at the second one, that is superheating the steam. So, if we go to discuss that particular aspect, that is superheating the steam. We shall discuss this particular aspect by drawing the processes in TS plane. So, if we go for the TS diagram, this is P condenser and this is P boiler. You know that this is 1, this is 2, this point is 3. Let us briefly draw the schematic of the power plant. So, this is point 1, 2, 3, 4. It is not mandatory that always you have to consider inlet to the pump should be denoted by point 1, that is up to you. We are trying to stick to the same notation exactly what we have followed in the previous classes. So, this is W out, this is Q out, this is Q in and this is W in, this is turbine. Now, you see that if we allow steam to expand in the turbine from point 3, and we can get 0.4. So, this is basically what we have seen in the context of simple Rankine cycle, right. Today, we shall discuss that if we allow steam to be superheated beyond 0.3. So, if I try to identify that particular process here, say we are allowing steam to be superheated beyond 0.3 and this is 0.3 prime and this point is 4 prime. So, you can see that if we allow steam to be superheated beyond 0.3, this is the additional net work we are going to get. So, this is delta W net, I am writing in the specific form. So, if you look at carefully that by superheating steam we can get this additional delta W net, probably it is because of this reason efficiency can be increased, because efficiency is equal to W net divided by Q in. I am writing in specific form. So, this is basically for the simple Rankine cycle. Now, I can write the expression that is eta simple Rankine with superheating steam, then it is W net plus delta W net divided by Q in. This is very important. Will this Q in will remain simply Q in, or to achieve this extra work output we need to supply more heat? That you can easily see that if we allow steam to be superheated from point 3 to 3 prime, we also need to supply additional amount of heat which is required for superheating this steam. So, here we can write delta Q in. All these are specific quantities. Question is, so you know that we are getting, so both the quantities written in both in numerator and denominator, they are increasing by these small quantities. So, which one the relative increase of W net, if the relative increment of delta W net is greater than the increment of delta Q in, then we can say that the efficiency of the simple Rankine cycle modified with superheating would be higher than the simple Rankine cycle. So, that means if we go to the next slide, that means eta simple Rankine with superheat will be equal to W net plus delta W net by Q in plus delta Q in. Now, see, it is very important, this delta W net by delta Q in is greater than W net by Q in. This is what is seen in practice. If we go back to this slide, see, I mean, why this delta W net, I mean delta W net, we are talking about delta W net. So, this is nothing but QH minus QL. So, you can see that if we try to superheat steam beyond 0.3, we need additional amount of heat to be supplied for this process, for the superheating. Additionally, if we allow steam to be superheated from 3 to 3 prime, you can see from the schematic depiction that that this is the so this is 4 prime. So, this is additional amount of heat that must be rejected in the condenser. So, this QL delta QL, right, or delta Q out. So, this additional amount of heat must be rejected if we allow steam to be superheated from 3 to 3 prime. Even after having this amount of heat rejection, can we really have higher efficiency? Yes, because you can say that already I have written that delta W net by delta Q in is greater than W net by Q in. Hence, you can say this quantity will be must be greater than eta simple Rankine. See, now, if you try to see it, this amount of why, see delta W net that we can see because QL, so QL increases. So, QL is increasing, but that increase in QL is basically in the linear that decreases the rejection, basically Q out, the amount of heat which is rejected, that is in this linear that is linear, while you know the amount of heat that we are supplying, that is not linear. So, this is non-linear. So, basically though there is some amount of heat must be rejected if we increase the temperature of steam beyond 0.3, rather if we superheat steam beyond 0.3, but this that Q out is not relatively higher than the amount of heat that is added, because QH, that is amount of heat which is added to achieve this delta W net, which is non-linear. I mean heat is added non-linearly, while heat is rejected linearly. Okay. So, if that is the case, that we can achieve the higher thermal efficiency. One question is, advantage is that, very important advantage is that by superheating steam beyond 0.3, we can increase the quality of the steam at the exit of the turbine. Okay. So, this is very important, one of the important advantage. So, advantage is quality of steam at the turbine exit improves. That is very important advantage. Number 2 is thermal efficiency of the cycle increases, right. Let me write here. So, that is 1 minus Q out divided by Q in. As I told you, this is also increases, this is also increases. So, Q out increases as compared to this simple Rankine cycle for this particular case, Q in also increases, but the increase in Q in is non-linear, while the increase in Q out is linear. That is easily observable from this TS diagram. So, the increase in Q n is taking place non-linearly, while the increase in Q out that takes place linearly. So, it is because of this reason already I have written that delta W net by Q in becomes higher than W net by Q in. The resultant effect is the increase of the efficiency of this Rankine cycle with superheating. So, these two are the advantage. Disadvantage I am not going to write here, but you look at, see, if we try to increase the temperature of steam beyond 3, additional arrangement must be there. So, I am not talking about that additional amount of heat must be supplied. By increasing the superheat, by increasing the temperature of steam beyond 3, that is we are going to increase the average temperature at which heat is added to the in the boiler. So, efficiency will increase, but to achieve that in practice, special arrangement needed, and which is costlier, not only the initial cost, but also the operational cost. So, the superheating process requires a special arrangement to be done inside the plant, inside the boiler to be precise. Not only that, so apart from the initial cost, we need to have proper maintenance during the operation of the plant. So, operational cost is involved. So, that is one of the disadvantageous feature. Second is, we cannot increase the temperature of steam arbitrarily, because that is restricted by the metallurgical consideration of the turbine blades. So, you know that we are increasing. So, this is basically again sensible heating. So, we can increase steam temperature from 3 to 3 prime, even 3 double prime, quality will keep on increasing at the exit of the turbine. That is of course a favorable aspect of this particular process, but we also need to keep in mind that the material, blade material should be able to withstand that temperature. There should not be any crack, thermal crack to be generated within the blade. So, this is again another disadvantageous feature. So, I am not going to write, but I am telling. So, next is, we have discussed about these two. Next is the increasing the boiler pressure. Increasing the boiler pressure. Again, let me draw the TS diagram. That is P condenser, that is P boiler. Say what we are doing, we are increasing. In the last slide we have seen that if we increase or if we superheat steam from 3 to 3 prime. So, I mean essentially what we are doing, we are increasing the temperature, which in turn increases the average temperature at which it is added. Okay. So, instead of superheating, as I told you that it requires special arrangement to be done inside the boiler. Not only the initial cost, but also the operational cost involved with this particular arrangement. So, I mean instead of looking at that particular point aspect, can't we increase this additional heat. So, basically what we are doing, we are supplying this amount of additional heat. So, can we supply this amount of heat even at a constant temperature in the boiler itself. So, as I told you, this steam which will be generated in the boiler, that will be again taken through some special arrangements, so that steam can be superheated. So, instead of doing that, if we look at another way of getting this amount of additional heat, but at a constant temperature inside the boiler, and that is nothing but increasing the boiler pressure. So, idea is just for the discussion. So, what we are doing, we are increasing temperature up to 3 prime. So, without superheating, we also can increase the temperature, or we also can achieve the steam temperature up to that by increasing the boiler pressure. By how? Say we are superheating steam up to this particular point. This is 1, this is 2, this is 3, this is 4. Now, can we increase boiler pressure? Let me draw using different another color. So, this is the temperature. Maybe we can have so this is 2 prime, say this is 3 prime, this is 4 prime. Okay. So, this is the concept. You know that without superheating, what we are doing, we are trying to achieve this additional amount of heat. I mean we are trying to increase the average temperature of heating by increasing boiler pressure from P boiler to P boiler dash. So, you know that the temperature is 3 and 3 prime, the temperature, these two temperatures are same. So, what we are going to have? We are going to have additional amount of W net, that is the hashed portion. So, this is plus delta W net. So, if we increase boiler pressure, that means if we allow boiler to operate at a higher pressure, we can achieve this additional amount of heat that we used to get by superheating steam in the earlier case. So, I mean here, but we also, if we look at this TS diagram, we also can see at the cost of this delta W net, we are also having this is the amount of work that we are not getting now. So, this is minus delta W net, right. So, if we do not superheat steam, rather if we allow boiler to operate at a higher pressure, probably we can get the same average temperature at which heat must be added to the cycle. So, if we do so, you can see that we will be getting, this is the amount of delta W net, this is the amount of delta W net that we are not getting, because that is you can see from the schematic depiction. So, you know that so this is basically these two delta W net are equal. So, you may ask me a question, okay, we can have this particular method. So, that means we are allowing boiler to operate at a higher pressure. So, that superheating arrangement is not required now. We can have the same temperature at which it is added to the cycle, though we are getting delta W net by operating boiler at higher pressure, but at the same time we need to compromise this amount of W net. So, this plus delta W net and minus delta W net, these two are equal. So, they will cancel each other. Now, if you look at carefully, though we are going to compromise this delta W net, but we are getting plus delta W net. So, this plus delta W net is almost equal to minus delta W net. So, the overall effect is null. So, there is no additional effect, but if you look at the stage diagram carefully, you will find that by allowing boiler to be operated at a higher pressure, we are going to reduce, this is delta Q out. So, if we allow steam to be superheated beyond up to this point, then this amount of, and now if we allow boiler to be operated at a higher pressure, probably we can save this amount of heat rejection in the condenser. So, this is basically the quantity we can save. So, what we can do? We can reduce the amount of heat that must be rejected at the condenser, in the condenser, if we allow steam to be boiler to be operated at a higher pressure. So, we are not going to compromise the mean temperature at which heat is added. We are also not going to get additional W net, because these two will cancel each other, but we can reduce delta Q. So, we can reduce Q out, right. So, you know that efficiency of is nothing but 1 minus Q out divided by Q in. If we can reduce this quantity by having this special method, then we can increase the efficiency of the cycle. So, eta Rankine with higher boiler pressure will be greater than eta simple Rankine. Okay. So, this is the concept. So, we can increase efficiency only by reducing the amount of heat that will be rejected in the condenser. So, by saving certain amount of heat rejection, we can increase the efficiency of the Rankine cycle modified with this increasing boiler pressure, because the gross effect due to delta W net that we are going to get out of from this particular higher boiler pressure, and this addition reduction in delta W net due to this superheating will cancel each other. So, the gross effect is increase in efficiency, but disadvantage is advantage is that we do not require special arrangement for superheating this steam. So, if we can eliminate it, there is no need of initial cost as well as the operational cost for this special arrangement, but disadvantage is that by increasing boiler pressure again we are going to deteriorate the quality of the steam at the exit of the turbine. So, I am writing the steam quality at the exit of the turbine will be poor. So, this is the disadvantage. Okay. So, now if we try to discuss that, in the last class we have discussed about lowering the condenser pressure. If we lower the condenser pressure, we have seen that maybe you are going to have a particular condenser which will operate and at a pressure which is less than atmospheric pressure, though we cannot reduce condenser pressure drastically, but even then we need to compromise the quality of the steam, that is what we have seen. Today whatever we have discussed, that superheating the steam, only disadvantage is that we need additional cost for the installation of a special system for superheating as well as the operational cost, fine. And also that we should be careful about the selection of the turbine blade material such that a particular material would be able to withstand that high temperature. While coming to the third option, that is increasing the boiler pressure, what we can see that though we can increase the efficiency of the cycle, but again we need to compromise the quality of the steam at the exit of the turbine. So, considering all those, that although we have discussed about the modifications of simple Rankine cycle, but none of these modifications what we have seen from the discussion is suitable for the power plant, essentially to have higher efficiency without inviting any additional problems. To this particular end, that is though modifications are there, employing either of these modifications we can increase the efficiency of the cycle, but at the same time we are also going to introduce another problems. Reheat cycle seems to be an alternative, to be precise, for the increase in efficiency of the plant, essentially by exploiting the high boiler pressure and superheating the steam, but at the cost of increasing the quality of the steam at the exit. So, let me tell you again what we have discussed, that either lowering the condenser pressure or increasing the boiler pressure, we need to compromise the quality of the steam. If we need to go for superheating the steam, then we need to again consider the additional cost involved with the initial as well as the operational cost, operational issues. So, initial cost will be high as well as operational cost will be high. So, I mean we can see that though we can increase efficiency, but we are going to have several other problems. Reheat cycle offers an alternative. The advantageous features are reheat cycle increases, reheat cycle offers higher thermal efficiency by exploiting high boiler pressure, superheating the steam and also eliminating the high moisture content of the steam at the exit of the turbine. So, reheat cycle which is provides an or seems to be an alternative to increase the efficiency. We can increase cycle efficiency, that means we also can look for, we also can expect that the efficiency of the plant will increase, because essentially all the processes will be compared by this particular cycle. So, all the processes of a power plant will be compared by this reheat cycle. So, seems to be an alternative to increase the efficiency by using high boiler pressure and superheating the steam, but eliminating the high moisture content in the steam at the exit of the turbine. So, this is very important, you know that already I have written, let me tell you. So, this cycle seems to be an alternative, we will discuss. We are claiming that this cycle will offer high efficiency, thermal efficiency. If you would like to have it, we need to have high boiler pressure, that means the boiler should be operated at a higher pressure. We also need to go for superheating the steam, but if we can have these two, that is high boiler pressure, and if we can have special arrangement that we can increase the superheat of the, we can superheat the steam, we can eliminate the probability of having high moisture content in the steam at the turbine exit. So, you may ask me a question that if we again go for superheating the steam, so idea is we will be using high boiler pressure. If we use high boiler pressure, that then we will be superheating the steam, but the degree of superheat should be controlled. So, if we allow boiler to be operated at a low pressure, then the degree of superheat required, the degree of superheat that will be needed to achieve high thermal efficiency will be very high. If you would like to have high degree of superheat, then probably arrangement should be again much more complex, and initial as well as operational costs will be higher. So, instead we are thinking to increase high boiler pressure, so that the degree of superheat should be within the our control, that means within a controllable limit, and also if we can superheat, probability the moisture content at the exit of the turbine also can be reduced. So, the idea is to use high boiler pressure, so that the degree of superheat can be reduced. Still we need to go for superheating, so that moisture content at the exit of the turbine can be reduced. So, if we can do it, probably we can increase the efficiency of the cycle, and that is what is the reheat cycle. So, with this I stop here today. and in the next class we shall discuss about the reheat cycle and we shall go for its analysis. Thank you.